Hello and welcome to a new video. This is the continuation of a video that I uploaded right before this, which is on exponent rules. We're going to do part 2 of this. So in the first video, we talked about exponents in general. We talked a little bit about negative exponents and what having a 0 as an exponent would be, but we're going to talk much more about it in this video. And we also went over some rules. I'll remind you of those rules real quick. It's the first 3 that are on here. If we have two things multiplied together with the same base, we can combine them by adding their exponents together. Because the way exponents work, if I have something like x squared and x to the 4th, it's saying we've got x times x, and then we've got x times x times x times x. So together we have 6 x's being multiplied together, and that's why we can combine it into just having x to the 6th. So the rule is that if we have multiplication in between two things with the same base, we can add their exponents together to simplify. The next rule is a power to a power. So if we have something like x squared and then we raise it to another power, we're saying I have x squared and I'm multiplying x squared together 4 times. So x squared, x squared, x squared, x squared, which in all means I have x to the 8th. So this rule is that power to a power, you'll almost always, or like 100% of the time, see parentheses involved here. We just don't usually write x squared to the 4th without parentheses. So you'll see parentheses. That'll kind of be a big clue that, hey, I think I need to multiply these together. But you also can sit and think, okay, I've got x squared, but I've got it 4 times, so that makes x to the 8th. So for this second rule, we multiply our exponents together. The third rule, if we have more than one thing in parentheses, but everything inside the parentheses is multiplication, we are able to almost, it's like a distributive property kind of. We don't call it the distributive property, but it should seem kind of like that, that everything inside the parentheses needs to get that power that's on the outside. So if I have x times y and it's to the 3rd power, that ends up being x cubed, y cubed. So just whatever's inside is going to get that exponent. And then we also can combine these 3 rules. We can combine all the rules together and end up with some interesting problems at the end of it. But here's a new rule, like 2 new rules, I guess, that we didn't talk about last time. It has to do with division instead of multiplication. And so again, I'm going to explain to you, try to explain why this is, so that you'll believe me, and also so that if you forget the rule, maybe you'll still be able to come up with the right answer. So if I have x to the 5th over x cubed, here's what it's saying. We have x times x times x times x times x on top. There's 5 of them. X cubed on bottom, so x times x times x. If you remember back to the early days of fractions, at some point maybe you wrote out numbers where it would be like 2 times 3 on top and like 2 times 5 on bottom. And then you said, oh, well, I can cancel the 2 out. It's on the top and the bottom because they're the same. And together, 2 over 2 is 1. So using that same idea, if we have x's on top and x's on bottom, we can cancel them out. Now, I have to do it like a pair at a time, like this x and this x, this x and this x, this x and this x. So how many x's am I left with? I'm left with 2 of them right here. And then they're on top of the fraction. Nothing is left on bottom, so there'd really be a 1 on bottom. So I have x squared on top and 1 on bottom, which is really just x squared. Let's think about how that works. We had 5 on top and 3 on bottom, so 3 canceled out from each. So we can think of this as subtraction. 5 minus 3 gave us 2. Now, there is a slight issue with that whenever we look at a problem like this next one. Because if you try to subtract, depending on how you subtract, you may or may not come up with the right answer. And we obviously want to come up with the right answer. So let's break this down. We have x squared on top, so x times x. And we have x to the 6th on bottom. 1, 2, 3, 4, 5, 6. So when we go to cancel these out, there's 2 on top and 2 on bottom in common that we can cancel. But what happens when we cancel everything on top? When I canceled everything on bottom, I stuck a 1 on bottom that then was in my way, so I erased it. If I cancel everything on top, I put a 1 on top instead. And this time the 1 matters. When we have 1 on bottom, well, x squared over 1 is just x squared. But when we are left with 1 on top, we need to keep that 1 on top and then figure out what's on bottom. X, 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 x. There's 4 of them. So this ends up simplifying to be 1 over x to the 4th. Now let's see if we can figure out how we could have come up with that using this idea of division means subtraction. So if I do, there's two ways to do it. There's more than two probably. But here's kind of the two ways that you can choose to think of it as. The way I like to think of it is I go, okay, 2 and 6. I'm going to subtract those. 6 minus 2 is 4. But because there is a bigger number of x's on bottom, I know that I need to put that 4 with x on bottom, not on top. It doesn't make sense that if I have x squared over x to the 6th that I'd put x to the 4th on top of my fraction, because there weren't 4 x's on top of the fraction at all. So instead I think, okay, I'm canceling out an x squared for the top and the bottom, so it leaves me with x to the 4th on the bottom. The other way to think of it is to say, well, I'm going to subtract like normal, but I'm going to do top minus bottom, which is normal. I'm going to do top minus bottom, which gives me 2 minus 6, which is negative 4. Okay, so if I do that, if I say, well, 2 minus 6 is negative 4, well, this is where in the last video when we talked about negative exponents, we can rewrite this by moving it down to the bottom of our fraction, and that changes it into 1 over x to the 4th. And that's actually another like kind of proof or reinforcing of this idea of negative exponents, right? Isn't it so cool that it works this way, that like we cancel things out and okay, we got x to the 4th on bottom, but also if we just do 2 minus 6, we get negative 4, and that tells us to move it down to the bottom. I don't know, I think it's cool. So that's basically two different ways you can think about it. That, okay, if I think of where should my x's end up because which one of these was bigger, that's one way. Or we can just say, I'm going to subtract, and if I end up with a negative exponent, I'll move it down to the bottom. Whichever way you like better. Let's look at power of a quotient. So this is basically the same as product, power of a product. Because if we have a fraction inside, we are basically just going to say everything still needs this 4th power. So x over y to the 4th power ends up being x over y times x over y times x over y times x over y. So when we multiply fractions together, we just multiply the numerators together and multiply the denominators together. So this ends up being x to the 4th over y to the 4th. So we basically continue this idea of if you have parentheses and you have an exponent on the outside, everything inside of the parentheses is affected by that exponent. 0 exponent. So 10 to the 0 we talked about in the last video is 1. So if you don't really understand why it's 1 and want to know, maybe you're okay with just accepting it, maybe not, then go back to that video and check it out. So 10 to the 0 is 1, but really anything to the 0 is 1, with the exception perhaps being 0 to the 0, which is probably more likely to be considered undefined than anything else, in my opinion. I haven't actually looked up to see what the consensus is from the math community. Negative exponents, like we talked about up here in this quotient of powers, is telling us that this is really a fraction. 10 to the or a decimal, however you want to look at it. 10 to the negative 2 is really 1 over 10 squared. And so we can make that be 1 over 100. Just if you have a negative exponent, whether it's on top or bottom, if we move it to the place it's not, it makes it positive. So x to the negative a here, it moves down and becomes 1 over x to the a. So let's give some problems like this a try. So our instructions, just like last time, say simplify. Your answer should contain only positive exponents. So one of the important things here is that on J, 7n to the negative 2, that negative 2 is only affecting n. If they wanted this to be, if they wanted the 7 to be affected by that negative 2 as well, they would have had to put parentheses around it to show that the 7 also is being affected, and they didn't. So what that means is that whenever I move things around, 7 has its own exponent of 1 because we didn't write an exponent. N has an exponent of negative 2, so we're just going to move that n down to the bottom, leave the 7 on top. And our answer ends up being 7 over n squared. And that's it. For k, it asks us, what is k to the 0 power? Well, anything to the 0 power is 1. So our answer is 1. Those are legitimately some of the best problems ever. Once you get the hang of this, if you see something to the 0 power, you just go, no, it's 1. And if there's other stuff in the problem that's not to the 0 power, you just work out what the rest of it is. It's pretty great. L, we have 2 letters here, so we can't combine things with different bases, just like we don't actually really combine, like we can't combine the 7 and the n squared on J. So instead, we take this a to the negative 3 and say, I want to move it down to the bottom so it has a positive exponent. B to the 4th is fine. It already has a positive exponent. So we've got b to the 4th over a cubed as our answer. So that's it. Okay, this is kind of like on the simple side of things, obviously. We can make it more complicated by combining our rules or adding more letters or whatever, but that's the basic idea. So speaking of combining rules, this is actually going to combine our multiplication properties with the fact that we have negative exponents. So there's more than one way to approach this, and I'll try to show you kind of both ways. When we see 3x cubed times x to the negative 2, probably the easiest thing to do is actually say, I'm multiplying these together, so I just need to add their exponents. And if we do that, if we do 3 plus negative 2, we get 1, which means that this simplifies to be 3x. The other way to do it is to say, well, I'm going to move this down and give it a positive exponent. And so we'd end up with a situation like this, 3x cubed over 1 times 1 over x squared. And we could write that together as one fraction. And then we could say, well, now I can subtract the exponents, right? 3 minus 2 is 1. So we end up with 3x to the 1st, or just 3x. So that's 2 different ways of thinking of the same kind of problem. And so on each of these, actually, we have those 2 different methods. My preferred method is probably to go ahead and add the exponents, and then if I end up with negative exponents, then I'll move them. For instance, here, we've got v to the 0. Oh, that's just 1. V to the negative 5 and v squared, those add together. Those exponents see at negative 3. So nothing happens with the 2 because just it's the only whole number here. So we get 2v to the negative 3, and then we'd say, okay, well, it says my answer should only contain positive exponents, so I'm going to move that down to the bottom. The 2 gets to stay. The 2 has its own exponent of 1 that we just are lazy and we don't write. But the v needs to move down so that it'll have a positive exponent. O looks complicated. It's really not that bad, though, because again, we want to break this up into really 3 different questions. What's the whole number going to end up being? If I have 5, 2, and 7 that I'm multiplying together, 5 times 2 is 10, 10 times 7 is 70. So we're a third of the way there. Then we check out the r's and we say, well, I can combine these r's by adding their exponents together. So I can do 2 plus 4 plus negative 3. So that's 6 plus negative 3, which gives us 3. So this will be r cubed, or like I like to say, r cubed, like a pirate. And then we look at the q's, and we say, okay, 4 plus negative 1 plus negative 7. 4 plus negative 1 is 3. 3 minus plus a negative 7. 3 plus a negative 7 is negative 4. So this would be q to the negative 4. And then we go one step further to move the q down to the bottom because it has a negative exponent. But the 70 and the r cubed stay on top, like this. So that's our answer. Now, again, there is another way to do these with negative exponents, another main way, I guess. We could start off by moving everything that has a negative exponent down to the bottom of a fraction, and then subtracting exponents from top to bottom, or things like that. That's totally fine. That's a legit way to do it. I like doing it this way better, but as long as you're getting the right answer and not just looking into it, then, it's probably fine. Here we've got power to a power. So this is where we multiply the exponents together. And really, trying to do it the way where we just reason it out is a bit harder here because of the negative exponents. So if your go-to is trying to think of this as how many times do I have a to the negative 2 if it's being raised to negative 3, then you might want to just change everything to positive exponents first. Now that's a bit tricky here actually. So that's why I would rather say, okay, I know that these are supposed to multiply together. And when we do that, we realize, oh, well, that's just 8 to the 6. Doing it the other way, like if you're fine with it being 8 to the negative 6, maybe ignore this because it might confuse you. If we change these to positive exponents, here's what that looks like. We would make it a squared on bottom, and then we'd have this negative 3. So then that negative 3 is going to end up affecting both of the things inside of our parentheses. So that's 1 to the negative 3 over a to the negative 6. And then we would basically move this down to the bottom to give it a positive exponent, and this up to the top to give it a positive exponent. And so that's how we end up back with a positive a to the 6th, or an a to the positive 6th up on top. And 1 to the negative 3, 1 to any power is actually 1. But if you want to think of it like, oh, I moved it down to the bottom and that's a positive 3, and do it that way, then that's fine. So this would just be a to the 6th. Okay, for Q here, we've got a 2 and a negative 5 we're going to multiply together. So that's k to the negative 10th. That means we need to move this down to the bottom, and it becomes 1 over k to the 10th. Or the other way to do it would be to say, I'm going to take this k squared, and since it's a negative 5, I'm going to move this down to the bottom. So I'm going to make it be 1 over k squared to the positive 5, and then I multiply the exponents together to get 10, or whatever it is I want to think about to get 10. On this one, I'm kind of torn as to whether or not, like, we could just go ahead and move this whole thing down to the bottom and give it a positive exponent. And so if we do that, if we give it a positive exponent, we haven't done anything to what's inside yet. We've just said, hey, I don't like that it's a negative 4. Let me move it down to the bottom so that now it's a positive 4. And then we would give everything inside the parentheses the 4th power. So it'd be 3 to the 4th, y to the negative 24th, and z to the 8th. And well, we need to move the y up to the top because it has a negative exponent. But these other things stay on bottom. 3 to the 4th is 3 times 3 times 3 times 3, which is 81. So our answer ends up being y to the 24th over 81, z to the 8th. Looking at the order I put these questions in now, I'm a little bit confused about whether or not this is the best order to do them in, but it's fine. Here we're using the quotient property. So the fact that I have x to the 8th on top and x to the 5th on bottom, 5 x's of each would cancel, so we'd have x cubed left, and it'd be left on top because x to the 8th is bigger and is on top. But what do we do with the 5 and the 10? Well, essentially what we're doing is actually splitting this up kind of like this, so that we can say there should not be that big a gap in between the dot and the second fraction. We say 5 over 10 simplifies to be 1/2, and x to the 8th over x to the 5th ends up being x cubed, technically on top, and then we can combine these and say this is x cubed over 2. So basically I came up with that by doing 8 minus 5 to get x cubed, and 5 over 10 to get a 1/2. We could leave the 1 on top with the x cubed if we wanted to, but we don't have to write it there. T, we've got y to the 4th over y to the 6th. So again, we can use subtracting exponents on this and either say, I'm going to do 6 minus 4 and get 2, but it goes on the bottom because look, there's more y's being multiplied on bottom than on top. Or we could say 4 minus 6 is negative 2 and rewrite this as 3y to the negative 2. And then say, oh, I need to move it down to the bottom to make it a positive exponent. Whichever one of those two you prefer would be great. U. We've got 3 things basically to do here because 2 over 6 simplifies into 1/3. M over m cubed simplifies because we have an m that we can cancel out. 3 minus 1 is 2, so that'd be 1 over m squared because there's more m's on bottom. Remember that m and n here without an exponent have an exponent of 1. N to the 7th over n to the 1st. That subtracts and gets n to the 6th. And then we'd say, okay, well, we just need to put all this together. There's n to the 6th on top and 3m squared on bottom. I normally don't actually write it out like this, but I thought maybe that would be easier to kind of get the idea of why it is the way it is. Because we're basically breaking it apart and then putting it back together. Breaking it apart so that we can do the different pieces and then putting it back together as our answer. That's how we deal with quotients. Second to last slide here. So this is almost as complicated as it gets. Actually, the last slide is really fun. I added it with the intention of it being a great addition. That was dumb. I don't know why I said that. Okay, so let's see. Okay, we've got 5 over 4, which doesn't simplify, so our answer is going to end up with a 5 on top and a 4 on bottom. X squared over x to the negative 5. There's two ways to approach this. Either we can say I'm going to subtract 2 minus negative 5, which really means do 2 plus 5. Or take this and move it up to the top so that it's x to the positive 5. And then that shows you more obviously, right, that x squared and x to the 5th, those need to be combined by adding their exponents together. Whichever way you do it, we should end up with x to the 7th on top. Then the y to the negative 4th and the y to the 3rd, again, either we need to do subtraction, negative 4 minus 3, which gives us negative 7. So that's a y to the negative 7 on top that we'd move down to the bottom. Or we could have moved y down to the bottom, this y down to the bottom before we did that. So we'd see, okay, y cubed and y to the 4th together make y to the 7th on bottom. So again, there's more than one way to think of this. You want to figure out what makes the most sense to your brain and use that method. So there we go. This seems a little out of place. Maybe I at one point maybe had another, like a negative in here to show that, hey, when you square a negative, it becomes a positive, but I don't know. Can't remember now. If we've got a to the 4th over 7a squared, then we square it. Everything inside needs to get squared. But I could go ahead and simplify these first. A to the 4th over a squared ends up being an a squared on top. The 7 would stay on bottom. And then I need to square both of these things. So a squared squared, we would multiply those together and get 4. And then 7 squared would be 49. Okay, whew, x. Everything is to the negative 3rd power. So we can go ahead and simplify the m to the 0 and say that's 1. We can also do the n to the 4th and n to the 1st and say that's n cubed, just to kind of make things a little bit easier, maybe. As far as, if you think about PEMDAS, right, we're supposed to do parentheses first. So simplifying inside the parentheses is something we should do if we can. It usually makes it easier. That being said, like, I could actually raise all these to the negative 3rd and then simplify, and I would get the same answer. But if you're not sure that that's something you can do, you'd want to stick with parentheses first because of, PEMDAS is a good thing. M to the negative 7th to the negative 3rd, I want to multiply those together, and then n to the 3rd to the negative 3rd, multiply those together, and then I do have a negative exponent that I want to move down to the bottom. I get m to the 21st over n to the 9th. Whew, all right, last slide. Now, 7x to the 0. Well, x to the 0 is just 1, so this is really 7 times 1, which is 7. Now, this is honestly to bring up the idea from polynomials, which, if you're watching this not this current year, then maybe I'll do this in the right order. So you won't have talked about polynomials yet. But if you've talked about polynomials, and if you've talked about what is the exponent for x of something like 7, which does not have an x, this is why it makes sense that we could call this a degree of 0. Because we can put an x to the 0 next to whatever we want, and it doesn't change what we have. Now, normally we don't need to do that, but we could do it. Putting this x to the 0 here just tells us, hey, the degree is 0. There are 0 x's here, and so it ends up going last in our standard form anytime we do it. So that's what that's all about. Z. Doesn't this look like a really fun problem? And by fun, I mean it might be terrible. Have you ever heard like a story about, or had this happen to you? A teacher gives out like a quiz, and the very first thing says, or they say, make sure you read the whole quiz before you do anything else. And the quiz is like super long and hard or complicated or things like that. But if you read the very last question, it's like, don't do anything, just turn in the paper or throw away the paper or something. And the point of it is, you have to follow the instructions, right? And the very first thing said, read all the instructions. The very last thing said, don't do anything. So yeah, this is kind of what's happening here. Because if I look all the way at the end, I have this giant parentheses and all of it's to the 0 power. And so if I think about that, if anything to the 0 power is 1 and this is to the 0 power, then the answer is just 1. So I didn't have to do any of that work inside to simplify this. You might do it for fun if that's something that you're into, but I didn't have to because it was all to the 0 power. Thanks so much for watching. Just kind of a by the way, like I feel like this is something that it's really hard to see right now why this would be helpful. It basically is us trying to add some skills to our algebraic reasoning skills so that we can work on combining things together later on. And so it'll be a little bit maybe before you're like, okay, well, I get why we did this. And that's fine. But it is helpful to be able to know how you are allowed to combine x's and how you're not allowed to combine x's and things like that. So that's what this was about. If you're not already subscribed, what are you doing? You should press the subscribe button. Everybody's doing it. It's so cool. Just kidding. But a lot of people have. And also hit the thumbs up button to tell me that you like the video or that you like me or that you have positive feelings in general. Thanks so much. Bye.